Let's find the exact value of the following inverse trig functions. In part A, we're looking at sine inverse evaluated at negative square root of 2 divided by 2. By definition of our inverse trig functions, recall that the domain of inverse sine is negative 1 to 1, and the range of this function is negative pi divided by 2 to pi divided by 2. By the definition of an inverse trig function, or an inverse function in general, we have that the sine inverse of the square root of 2 divided by 2, which is equal to y, only occurs when we have that sine evaluated at y is equal to the negative square root of 2 divided by 2. And recall, by definition, our y value in both cases is the acute angle that forms our right triangles. Looking at sine evaluated at y, having an output of negative square root of 2 divided by 2, we know an output value being negative means that our input value has to be from the fourth quadrant, since every input value from the first quadrant is going to give us a positive output. Now we form our right triangle using this y value, and by the definition of sine, we get the length of the opposite side is a negative square root of 2 divided by 2, and the hypotenuse is given by 1. Now, we can either realize two things. The first thing is that this is going to be a 45, 45, 90 triangle, or the only time sine of y is equal to the negative square root of 2 divided by 2 in the fourth quadrant is when we have a negative pi divided by 4. In either reasoning, we can conclude then that y is equal to negative pi divided by 4. So inverse sine evaluated at negative square root of 2 divided by 2 is equal to a negative pi divided by 4. Moving on to part B, we're looking to evaluate the inverse cosine at negative square root divided by 2. And also recall that the domain of this function is also negative 1 to 1, and the range of this function is 0 to pi. Again, by the definition of an inverse function, we're given that our cosine inverse of the negative square root of 2 divided by 2 is equal to y if and only if our cosine evaluated at y is equal to a negative square root of 2 divided by 2. Again, our y here is going to be the angle that determines our right triangle. And the values on this hand side tell us what the sides of our right triangle are going to be. Since we're looking at a restricted domain of our cosine is between 0 and pi. That means our angle y should lie in the second quadrant. Since we're given our value negative square root of 2 divided by 2 is a negative number. And the only time cosine is negative between quadrant 1 and quadrant 2 is in quadrant 2. Again, this allows us to define a right triangle with the following sides. And again, we can see that this defines a 45, 45, 90 degree triangle, which means that the angle between this yellow line here and this blue line will be 45 degrees. Translating this into radians, we're going to get, if we call this angle y bar is equal to 45 degrees, which is equal to pi divided by 4. And y bar is the reference angle of y, and this means that the angle y is going to be equal to 3 pi divided by 4. In part C, we want to evaluate tan inverse at the value negative 1. And recall the domain of tan inverse is all real numbers, and the range of tan inverse is negative pi divided by 2 to pi divided by 2. By definition, we're looking for the angle that makes tan equal to 1, negative 1. Again, the only angles we're allowed to look at are in quadrant 1 and quadrant 4, because the range of our inverse tan is between negative pi divided by 2 and pi divided by 2. So let's go ahead and draw a picture. So tan is always positive in the first quadrant, which means our angle of y has to lie in the fourth quadrant. And by definition, tan of y is equal to -1 in this problem, which means by definition, we're going to get tan to be equal to the opposite side divided by the adjacent side, which means the opposite side has length -1 and the adjacent side has length 1. The length of the remaining side is the square root of 2, which means, again, this is a 45-90 triangle. Since this angle here that starts at the x-axis and lays on the hypotenuse of our triangle is moving in the clockwise direction, we're going to get this angle here as a -45-degree angle. So y in this case is equal to -45 degrees, which is the same thing as a negative pi divided by 4.